So welcome once again. And let me just go through our agenda today. It's going to be a very interesting session today. So this is me. I just already introduced myself. And at the same time, from 15:05 and 15:15, we'll be having some welcome remarks by Dr. Piranan. And then we will quickly move on to the presentation by Dr. Milad Zamanifar, who is the main presenter today. And then we will have a question and answer session, and we will like you to ask a lot of questions, and we will welcome you to leave those in the chat box, and not at the chat box, at the QA session, for QA box, and then we will have a closing remarks by Mohammad Nurul. So that's pretty much our plan today, and here are some housekeeping rules for all of you. You can all see a Q&A box just close to the closing downside, and please post your questions there. We are encouraging you to post your questions there, not in the chat box, but in case if you cannot find, then you can leave it at the chat box as well. Keep asking the questions whenever you hear. We will compile all the questions, and we will put them together at the end of Dr. Milad's presentation, and we would like to give the answers at that time. So do not hesitate, do not need to keep it writing down or in your memory. You just can write it whenever you feel like it. And you're welcome to leave your LinkedIn profile link at the chat box so that we can all get connected and know each other a little bit better. It's more of our opportunity to get connected. And you are welcome to use any native language. You can use Bangla, you can use Hindi, you can use Nepali language for asking questions. So for today, we have to get together our people from a lot of countries from ADPC side, and we can translate it for Dr. Milad so that he can answer correctly. And if any of you haven't zoomed in with any other kind of name rather than your own name, please change it to the format that your full name and then your organization, so that we can actually press, and where you are connecting it from, you can also leave it with us. And the slides will be shared. The slides from Dr. Milad will be shared with you at your registered email later on, possibly today. So you do not need to actually take any screenshot or write anything down, and feel free to just enjoy the session and ask your questions. In case of any technical queries, you are welcome to contact milad.zamanifar@adpc.net. I believe he will be providing the email address at the end of his presentation as well. So this is just for your reference for the time being. So since, let me just speak one or 2 minutes only on Care for South Asia project. So this is a Care for South Asia project is here to build climate resilience for the South Asian region. And there are several sectors Care for South Asia project is working on: agriculture, water, transport, policy planning, and finance. I'll not go into very much detail. So in the 3 countries this project is currently working on: Pakistan, Nepal, and Bangladesh. And for the resilient transport sector part, ADPC is working on at Nepal and Bangladesh. And today we are here because we understand that concepts and standards of resilient transport sector is a kind of a new and unique concept, and we want to build the consistency and our sensitization on the topics. And this will be a platform where we can ask our questions and get all of us on page, so that we can start building our own understanding on how to build our transport sector in a more resilient way. So without any further ado, here I think I would like to call upon our, just give me 1 minute. I'll just stop sharing my screen first. I think I have done it. So that is from my end. 1 minute, please. I'm trying to do one thing. Yeah. So without further ado, let me call upon on the stage Dr. Piranan, and he will be providing us the welcome remarks today. So he's the Director of Geospatial Information Department of ADPC, who is currently has been working here since 2010, a long time, I must say. And his technical expertise is in earthquake engineering and vulnerability assessment. He has completed his bachelor's in civil engineering from Chulalongkorn University in Thailand, and later on completed both his master's and PhD from Georgia Institute of Technology in USA. So Dr. Piranand, the floor is all yours. Thank you so much for joining today. And here's the welcome remarks from Dr. Piranand.
Thank you so much, Noreen. Good afternoon, everyone. For those of you who are in the same time zone as mine, good morning for those of you in Europe and Africa. And I heard that there was some registration from Canada as well. So good evening to all of you. I don't know if you were able to make it, but I want to quickly welcome everyone to the ADPC webinar. And the topic of our webinar today is climate resilient road infrastructure, focusing on getting the strategies and designs right. This webinar is organized through support of the World Bank under the regional program that Noreen had already mentioned. The project is called Climate Adaptation and Resilience for South Asia, or we call it CARE for South Asia in short. This is a 5-year regional program that has an objective of building capacity and building an environment for climate resilience policy and investment for different sectors. But the more interesting aspect of this project is that it brings together 2 very important international organizations who are already working on addressing climate adaptation and climate resilience issues in South Asia and Southeast Asia. And those are the Asian Disaster Preparedness Center, ADPC, as well as the Regional Integrated Multi-Hazard Early Warning System, or RAMS. So today we will focus on the transport sector. I guess everyone is all aware that the transport sector has suffered and will continue to suffer from the impact of climate change as well as climate extreme events. You have seen that roads and bridges in countries like Bangladesh and Nepal have been damaged from flooding, from extreme dry conditions, as well as landslides. While the increased precipitation and temperature over time will continue to deteriorate the conditions of the roads as well as the operation of these assets. We gotta work together to ensure that policies and investment decisions on these transport sector assets account for climate change. And they need to be made on evidence-based approach. So with that in mind, our team has been working with the countries, supporting the countries to conduct an assessment on climate change impacts as well as climate extreme risks. And the aim is to use such information as an evidence and as a baseline for deriving strategies, guidelines, and action plans for transport sector to be ready for such impact, both from the short and long-term horizons climate change. And in order to facilitate an adoption of the climate resilience planning by the countries, we'll be ensuring that the knowledge is not only developed, but also is chaired and maintained by the country's experts and decision makers. So this kind of webinar that we are organizing today is one of the means for us to raise awareness and build further understanding of everyone who attends it. So in today's webinar, we have our own expert, Dr. Milad Samanifar. He will first talk about the fundamentals of climate resilience. Then Milad will touch upon some misunderstanding and some arguments around the concept of climate resilience. He will talk about the applications of the concept of resilience and its limitation for the transport sector, focusing today particularly on the road infrastructure in Nepal and Bangladesh, the 2 of our pilot countries. His talk will be supplemented by best practices from other parts of the world. And that is important because then you will realize that the end impact of such climate resilient infrastructure planning and concept, how it will look like in the context of South Asia. We hope that you will learn a great deal from this webinar, but we also expect to learn from you as well. If you have any questions or any suggestions, please do share them during the discussion session that will come after Milad's talk. We will look forward to a very interactive session today. So let me close my welcome remarks today by thanking first the World Bank for the partnership and the trust that they had on ADPC. I want to thank RAMS as a technical partner of the project. I want to also thank the organizing team for this webinar. I know there's been a lot of hard work putting into this, getting this webinar as the way it is today. But most importantly, I want to thank every one of you who join and tune in for listening in for this webinar. Thanks for your interest in the work of ADPC. So at last, please enjoy the webinar. Thank you very much. I turn this back to you, Noreen.
Thank you, Dr. Piranan. That was indeed a very nice welcome remark for everyone, and a very nice sum up of the whole project for Care of South Asia as well. Now this is our time to move on to the next presentation by Dr. Milad Zamanifar. But before I introduce him, and I would just like to again remind every attendee of participants today that please change your Zoom login name in case you haven't already, and if possible, add your organization name as well. So it is very easy for us to recognize or trace you. With that said, and one more thing, since it's a virtual program and there is always a possibility that anybody of us can get disconnected, so Mr. Anish Joshi will be my co-host in case I get any kind of internet disturbance. So thank you for that. Thank you for understanding. And here I am gonna welcome Mr. Dr. Milad Zamanifar. He is a regional resident transport specialist at ADPC, PhD in civil systems, guest lecturer with expertise in transport engineering and different complex systems. At research level, he has been contributing to disaster risk management, decision analysis, and road construction domains. So I believe the floor is yours, Milad, and we are going to have a very interactive session today. So, and in between, please continue all of the, this is for all of our participants. Please keep asking your questions in the QA box. And in case if you have any difficulty, you are always welcome to use your own native language to ask your questions. Thank you. Milad, the floor is yours.
Thank you very much, Noreen, and thank you, Dr. Piranan, for the welcoming note. Is my slides visible?
Yes, your slide is visible and you are audible as well. Please go ahead.
Welcome everyone. Good morning and good afternoon. I am Milad. We are here to just talk about resilience of road infrastructures. I have also one house rule, and this is very simple. If you really need more elaboration, please ask question. I request you to ask any question regarding the content that might not be clear, regarding the content that might need more elaboration. So the outline of the presentation today is a very background information. Mainly, I would like to talk regarding the concept of the resilience, as how it developed. So the first few slides would be conceptual development of the resilience, and then we talk about the properties of the resilience in infrastructure context, especially with focus on roads. The way how we can start to conduct the resilience analysis through the scoping and problem structuring will be next focus of our presentation today, and adaptation solutions with a specific emphasis on robustness would be continuing our presentation. Final remarks, and after that I would be open to any questions that you might have. So I think we all agree that adverse impact of hazards and stressors that are related to the climate, or rather substantial, which directly contribute to economy and rehabilitation, maintenance costs and rehabilitation. That's why we are all here in this lovely day, right? So I wouldn't want to preach the converted already, but as we know, it's a global challenge. And of course, South Asia is not immune neither to the exposure nor impact and the risk from climatic hazard and stressors. In particular, from hydrometeorological hazards that are really our point of interest. You can see here that how the situation in the South Asia regarding the exposure is quite critical. Of course, there are various hazards. Among them, the main that is known for us as civil engineers and people active in road engineering is traffic load, and axle loading, which is causing distress and deterioration to road infrastructure. But for US, for example, that often climate data is already integrated in the design process, it's estimated that 36% of total damages for flexible pavements can be attributed to environmental factor and climate parameters, and of course 24% of the total damage for rigid pavements. So it seems that nonetheless hydrometeorological hazards are somehow changing with the rate faster than our adaptation process. And the same goes for the vulnerability of assets. They are commonly acknowledged that road infrastructures are vulnerable to several climatic and non-climatic factors. Among those, we identified some possible range of susceptibility to hydrometeorological hazards and climatic stressors in the context of road infrastructure under the Care for South Asia project. We are mainly focused on this region. And you can see, I don't want to talk too much about this because I think we are all on the same page that how hydrometeorological hazard and climatic stressors impose damage to different components of the road infrastructure. Not only the climate stressors, but also those stressors that are believed to be increased or pronounced due to the climate change, which usually the road assets will undergo during its design life, but for which it is not designed for. Among those, we can somehow speculate that climate change for some assets in the long run would develop more susceptibility, which directly translate to maintenance and rehabilitation costs. Although we can't really figure it out what is the exact amount, so the exact extent is unknown, but the trajectory is showing the sort of incremental flow. And it's for this case, on the worst case scenario, it's valid for a flexible pavement that it will rise in the future, specifically with regard to the fatigue cracking, subgrade rotting, and AC rotting. Of course, bleeding, raveling, and other deterioration would also increase, but the limited study focus on these three agents. So that's why resilience is an interesting concept. It's interesting concept in engineering for us. The lexical definition, the dictionary definition of the term resilience, is going back to its Latin origin, which is known to be springing back or bounce back. Resilience concept was born through the engineering, for mainly mechanical engineering and material science. But however, it has been mainstreamed through ecology and developmental psychopathology disciplines and domains. In field of developmental psychopathology of children, Professor Garmezi, somewhere around 1940s, 1950s, started to study disadvantaged children that experience some sort of trauma and stressful life events. Let's say war, abuse, violation, hospitalization, drug, and so forth, and find out that some of the outliers, some of the children, statistically outliers, were children who, despite undergoing extreme distresses and a stressful life event, end up just right. They just grow into the healthy individual, healthy adults, healthy in the clinical term, that they haven't exhibit some markers that can be attributed to the psychological disorders or diseases. So they name them as a resilient individual. In material science, on the other hand, it's more about the capacity of the material to absorb energy, but it is elastically deformed, and how it's restored the shape, the initial shape after removing the force. In ecology, however, Professor Buzz Holling, almost in the same era, in 1907, 1916, conceived resilience as the persistence of the relationship within the system, within the organic systems, under stress toward reaching a new equilibrium when the shock is removed. in complex systems domain, as it is our point of interest today, infrastructure systems are highly complex and highly interwoven, interconnected, and interdependent. Resilience is yet rather a young concept. We actually borrow it, or actually we have been imposed to use it from other disciplines, mainly from policy point of view. And this concept in systems engineering fall under the category of abilities, such as agility, changeability, adaptability. They usually end with ability as a suffix. Means some desired properties of a system, not necessarily the primary expected function, but some desired ideal, even a design engineer or a user would like to have this property, which are not always measurable with routine field inspection, let's say lab test, or in the case of classic engineering, measures such as safety or reliability that have been served the community for a long time. Reliability after World War I have been developed, and we as engineers, we never had a problem using it. But terms such as resilience came with the huge amount of, let's say, ambiguous and unclear domain, which is make it a little difficult for us to operationalize. Usually for abilities, this is the case, that they are introduced as a more of an abstract concept from the engineering community. But resilience, unlike other abilities, it's not developed by the engineering community, but and offered and suggested to the civil engineering community. Therefore, it has a huge conceptual fluidity, various definitions, numerous properties, capacities, principles, dimension, and conception. So here you can see, for example, some research discovered over 119 different definitions for the resilience. That is only until 2010. And when you see it in the infrastructure resilient domain, it can almost reach 50 different definitions with numerous properties. So, excuse me. So you see that some of the properties are here listed. But mainly 4 properties that Bruno in 2003 suggested have been welcomed through within the engineering community, such as robustness, rapidity, resourcefulness, and so forth. So the art here is to draw boundaries and limitation to the scale and the scope of the investigation of the resilience. Resilience of what? A resilience to what? So if you're talking about the community resilience, or we are talking about our assets resilience, because if you're talking about asset resilience, probably we will have a limited capacity to include, for example, this dimension of organizational dimension or social dimension. First of all, it was the four properties. Later on, the learning capacity have been added, but you know the problem is that the learning does not have an R to actually fit in the 4R. Therefore, we can see the learning capacity, we've seen the resourcefulness. We later on discuss more on that, about the properties of the resilience. So let's now talk about the definition. So when we see about the FHWA, Federal Highway Administration, they offer a definition like the ability to anticipate, prepare for, adapt to changing condition, and withstand, respond to, and recover rapidly from disruption. So it's kind of ideology. It's more of the goal than the objective. So when we see it, it's overly generalized as an ideal concept rather than the object that can really help us to use that. And it's kind of too much expectation from the concept of resilience. So how can we develop an road infrastructure that we can anticipate, prepare, adapt? So it's I think that's where the problem lies. And number of scholars and authors expressed their concern about the use of resilience as a fashionable of late, as a buzzword, as a non-operative concept in the engineering format. So technically, road agencies are charged to react to the mandate from the policy, at the policy level, from the users, from the public, to react and respond to the mandate of a resilience building without a tool or even practical definition. So personally, I can totally understand when the concept is decision makers in the road agencies are reluctant to go through it. Later on in 2016, actually through the summit in 2009, AASHTO actually provide more apologies, practical definitions and more easily conceivable definition as the ability of the system to provide and maintain an acceptable level of service or functionality in the face of major shocks or disruption to normal operations. So that, of course, is more conceivable, but yet it is not touching about the ability of the system to react to the shock, to the hazardous event. Here, as a seminal paper, Professor Ayub, I think, is in Maryland University right now, provided a concept trying to integrate various elements. So as you see, it's always about the performance. Some attribute that can reflect the performance of road infrastructure. So you might think about the performance of the road infrastructure in your area of expertise, about the mobility, travel time, physical condition, some sort of performance indicator that can reflect how the road asset is servicing the user. So here you can see that when the performance drops after the strike of the hazard, it's not always that it dropped significantly or in the loss occurred in just one moment, but depending on the robustness of your road asset, depending on the strength and physical condition of your asset, this can be brittle, ductile, or with the graceful degradation. So that's graceful degradation is what we are really looking at. So think of landslide, for example. That is a F1. That is immediately close the road. Think of, let's say, rotting. It might come after a summer of the extreme heat. It does not immediately exhibit itself on the road damage. And afterward, then there's a recovery in the blue arrows that how fast we can restore our road asset or road network. Let's think right here now that the resilience is not limited to the asset level, it's a network level property. So how fast we can actually restore it. So there's a temporal enhanced performance. At the end, we want to reach a point of performance like the previous event status, but there's a different trajectory screw as how we, in which rate we can reach that. So the more robust the asset is, the resilience would be higher. In the same time, in post-event, the more restorative, the more we are prepared and ready for recover the assets from the degradation, the resilience would also increase. So here we're talking about the temporal sensitivity of the resilience concept. It's very important. It's one of the most important actually argument within the definition of the resilience. If we see that as a property sensitive to the temporal periods, with temporal characteristics. So if the measures, resilient measure can be either ex ante, which is actually related to the activities before the event, which aims at reducing the hazard impact, or ex post, which is measures that relating to the anything happens after the event. Here is where in ex ante, here is where robustness actually contributing a lot, and redundancy, of course. So redundancy and robustness sit in the ex ante before the hazard and can be reached through preparedness activity. While rapidity, some come just right after the hazards, resourcefulness contribute to both phases. For example, if you remember the West Germany flooding last March, like August, I don't know exactly, they were relatively strong in post-event measures. Everything was quite good, but they failed to build redundancy and robustness through the risk assessment prior to the event. So if we fail in one of these phases or properties, we actually the planning for failure. And the both phase, ex ante and ex post, should be developed simultaneously. So ex ante, two main phase, before the adverse event, and ex post adverse after the adverse event. However, that's only valid for sudden onset hazards. For example, let's say flash flood, let's say earthquake. But we have also in road infrastructure context, we have a climatic stressor that acts as a slow set hazard, like extreme temperature, like heavy precipitation, monsoon seasons, that we don't see immediately the failure of the system due to their hazard, but they actually reflect themselves somewhere later, sometime later, as a form of, for example, stripping or raveling. And therefore, you can see that some other research actually discuss about how we should also consider the during an event. So this temporal sensitivity is actually recognized vastly in the community. So I actually finalized here that the concept of resilience infrastructure can be perceived as a degree of a processing, of a possessing of the set of capabilities, abilities that indicate both properties and behavior of the system. So it's matter if we are talking about the ex ante, we are talking about the statistic behavior of the statistic properties of the system. We are talking in a descriptive form. We are talking about how describe the current condition of the asset. That's what we are interested in. We are talking about the state of the system regarding the current condition and how it can actually withstand the hazards. Or we talk about the ex post, mostly interested in how a system, what a system does after the event. It's the dynamic and the normative. Normativity indicate how it ought to be, how it's expected to be, and it's relating to the behavior of the system. So in presence of the certain and major shock, until it's relaxed on the new state of equilibrium. From this comprehensive reach that we are expecting that the resilience cover, we are actually pushing the concept of resilience to address somehow. It's difficult to arrive at operational indicators with this wide spectrum of the expectation. Therefore, here is what scoping can provide. Strategic decisions. It's documented that report a failure rate of 50%. It gets worse once we use multi-criteria decision making, why we have different attributes, different decision factor involving. So without proper scoping and limiting the boundary of the problem, we won't be able to get a chance to solve it with a reasonable, let's say, computational complexity. But most importantly, we would not find the opportunity to understand the problem without disaggregating, break it down, and downscaling the problem through the scoping. For that, the most and critical step, I would say even the most often ignored step, is scoping. It is actually, we call it here now scoping, but the original term would be problem structuring. It is advised in the decision analysis literature. So the infrastructure resilience on a scope, starting with the dimension. We previously showed that it can be social, technical, and temporality, ex ante or ex post, before the event or after the event. Hazard system. Or we having a multi-hazard approach, or we focusing on a single hazard, and this hazard are all climatic or only, or mix of non-climatic and climatic. What is the life cycle? Do we consider, for example, climate at the year of the design or year of the construction, or we also consider climate change and how the climatic factor, let's say temperature, will rise in the future? A spatial scale, for example, are we trying to analyze the resilience of the one zone of the transport network in province level, in national level? That's also dictate the scope of our resilience analysis. And then what's about the system level? Are we seeing the resilience as a property of the asset, or we want to analyze the resilience in a network level? And actually, all of them are dictated by the level of efforts we are wishing to introduce to our analysis process. So level of effort or level of investigation are defined based on desired level of uncertainty and the scope that we want to consider. And this level of effort actually dictates what is a system level, what is a hazard system. It's almost, I would say, cumbersome, if not impossible, to provide a resilient analysis that have all the dimensions, all the temporality, all the intervention phase, like preparedness, recovery, multi-hazard, although that's what we seek. That is what we always hear from the keynote speakers, that we need a multi-hazard, all hazard included, the life cycle, system level thinking. But when it's when you put it on the paper, you want to do that really. You realize that you end up, of course, with the result, but the result does not is not associated with a sufficient reliability and sufficient certainty that can be used as an operational level. So let's talk about the properties now. They are very important. Just a moment. So redundancy, as we know, as the buffer capacity, I think that's quite a clear property. If one fails, another one component compensated. Let's say if we have a flash flood, design flood, we provide some additional culverts to compensate if the real flash flood exceeding our design flash flood, or reliability-based design, that where we introduce factor of safety, like some sort of coefficients that bring our design parameter a little bit higher. Alternative road for critical nodes. So when we want to, when we have, for example, a node that is significantly important for us, let's say provide the water of the community, or connect the community to the basic cares, then we would like to have some sort of contingency plan. Paved shoulder. If the landslide, for example, occurs, opposite shoulder can be used as a driveway. Then let's talk about a rapidity. It's very simple. It's quick recovery. So there are a huge amount of literature, for example, about the recovery planning since 1970. That time they didn't use the term of the resilience. So here we should signify the difference between concept of the resilience and term of the resilience. In disaster recovery planning, the concept of resilience have been used since 1970, but not the term. However, these days, the term has been used significantly, but the concept is quite missing. Another one is resourcefulness. That's a little vague. That's something that is difficult to quantify, but it's sort of addressing navigator resource and intervention in response to a shock, or for preparedness before the adverse, and of course, during an event. Like anything related to planning, finance, policy, knowledge, standards. So in Care for South Asia project, we actually having the different sectors who are approaching the concept of property of resourcefulness in the resilience approach. Robustness is what is we are more interested is about the structural strength and integrity of this asset, to extend the extent to which the system is not driven to zero. It's still performing, although the shock is there, stress is there, but the system can still provide some level of service to the users. For example, polymer modified bitumens that can improve the strength against extreme heat and rotting. Rigid pavement, they are showing quite a good performance regarding the inundation. Of course, we should not consider them naively as the fully resilient pavement. Anti-corrosion material in the maritime environment, and of course, the maintenance regime that we want to take over. Oops. So, but why do we need these all properties for our analysis, and why properties matter? They matter because they allow us to disaggregate an abstract concept like resilience, break it to the small parts, to a more analytically tractable and understandable component. They also are important since they assist with navigating proper attributes, defining the attributes, and evaluating resilience for our assets. So selecting properties are primary target of the scoping, and is a very important step toward arriving at indicators and measurement of the resilience. So here we want to go more technical, and we want to actually go through some examples. And for that, let's think about extreme precipitation and impact of the road assets. There are, of course, various failure can occur relating to different component of the road structure. Is it in the surface, in the base? So, for example, capillary effects, the impact of the trapped water between the base and sub-base, swelling and shrinking of the soils, and they can show their effect with the different distresses, right? Stripping, pothole, fatigue, reflective cracks, which are bottom of deteriorations, and so forth. What we should actually consider is that not always all the effects, all the adverse effects merge themselves in the immediate period after the stressor. So some of them are delayed. Some of them we just see them in after the season, after a winter, for example, after a summer. Some are having a jump effect. Some you can immediately see the effect. For example, force of water, flood, it's totally destroyed, and you can see it immediately. And some of them having the both properties. So you see the immediate effect, and you also they impact the rate of the deterioration in the future. So the damage will continue to impact the road. So I would like here to hold a quick quiz here, but first I would like to explain about different pavements. So let's say that we are decision makers, we want to make a decision, or design engineers, and we have three options. And we want to know which one, we want to actually come to this understanding that which is more likely to be resilient to heavy precipitation, because we already made lots of a study, for example, and realized that the road that we are doing in this area is exposed to heavy precipitation. So option A, asphalt concrete, 40 millimeters thickness, and with 19% air volume, with the use of bitumen, 67 penetration grade, plus 0.3% polyamide. Base would have a 10% 5 granule base. We will use undersill, edge drain, and under drain, of course, and subgrade arrive at the CB, California bearing ratio of 9%. The soil of the subgrade is the sand. Option B, however, a little more thicker, quiet dense with 4% void, and have a really strong binder bitumen because it is modified with SPS 5%. Base has 20% fine. We also use a semi-layer, a subgrade, CBR is 8, and the soil is clay. If you see on option C, there's again the very quiet open grade, 19% void, with the normal bitumen of 60-70%. Use of all the three options are using the undersill and semi-layer and so forth, and the soil is silt. So just have a look at the three options and just imagine what would be the best option against heavy precipitation. And there is no right and wrong. Actually, it's too quick to have a really right or wrong answer, but I want you just put thought on that. I would like to ask Apipal to, after a few 10 seconds, open the poll, and then you can just select option A, option B, and option C.
Now you can select it, the poll show.
At this moment, we have about 6 people who have participated in the poll, encouraging everyone to participate.
I believe it will be anonymous. So
yeah, the poll will close, I think, very shortly. So
Okay, we end the poll now.
Milad, everyone has chosen, 10 people has chosen option B actually.
okay, can I now close? Yeah, I can close. So let's think about it. Oh, it came up again. Should I share the results? No, I won't. So option, let's first see option B. Option B is quite interesting, of course. It's a little bit expensive, but it's a luxury. I mean, this SPS 5%. It's sophisticated design. It has a semi-layer. It's quite a strong structure, but it is not climate smart. And its render it such as cost ineffective, and there is a high probability of a maladaptation. So you might ask why? The bitumen is very strong. It's quite dense, and that's what we need to be permeable. But when you see, we are talking about the precipitation. It means the moisture-induced damage. And although polymer modified bitumen improve the rheological properties of the bitumen, but it does not really the best option for improving the chemical properties of the bitumen. And then we have a clay soil, means that it can very easily shrink and swell, and actually rendering us with a very unstable subgrade that can eventually move and transfer to the upper layer. Having this kind of subgrade exposed to the precipitation, it's not much important what kind of varying course you're using, because you're using just 4 centimeter very strong varying course. But another problem is the base of 20% fine. So base with granule base with 20% of a very fine aggregate, it's significantly capillary prone material. So it means that gravity does not have a much chance to let the water drain down. So there are lots of water will be stuck in the base layer and does not even reach the undersill, and you're aged right through the semi-layer. So you have a problem of the trapped water. So this is not the best option. I mean, you may make the company produce SPS CO rich, but you would not really much get a positive impact. Option C is very economically viable. You don't really pay some money, but it is partially resilient. I mean, it has a great base for draining off draining the water, but the wearing course is at risk because we don't have the moisture resistant bitumen here, and the stripping can happen very easily. So you might also think, what is this 90% void? 90% is used in the open grade mixtures. I will later on elaborate on that more. That's allowed to, it has a very high drainage capacity in the areas exposed to the storm is really a good option to consider that. And how it will impact react to the precipitation, I would say this data would not be sufficient. However, option A, it's a significant surface drainage capacity with 19% of voids through porous asphalt. Its subsurface is sufficiently conductive for the water. It means that it's allow really water to drain down, to reach the undersill and then direct it to the side ditch. And it's have a reliable subgrade. The sand for subgrade is very good in drainage. And using 3% of 0.3% of a fatty acid polyamine is quite a good anti-stripper, and which is also probably 20 times cheaper than the SPS. So I would say option A, but you can, in the practice, that might really change. Now let's zoom in. Let's zoom in just for the varying cores. Let's see how a small change in the small component of our road pavement system would change. Which varying cores, which top cut is more likely to be resilient to extreme temperature this time? So I'll explain a little bit. The first option is grade 0 to 11, very, very dense, 2%, thickness is 30 millimeter, and bitumen content is 6.8. It's quite rich mortar mixture. It's a void filled bitumen, 82%, with a high filler content, 9%. But Marshall stability is 900 kilogram, and it's a gap grade. Second option, the dense grade again, less bitumen with a high Marshall stability. And option 3, it's a 40 millimeter thickness, bitumen content of 5.3, and with a Marshall stability of 96. This is an open grade, like porous asphalt. The middle one is the usual conventional asphalt concrete, AC. And the option A is a gap grade. So what do you think about the extreme temperature sensitivity of these three options? Would you please pull up the poll? Okay.
I think we have the answers, Milad. You can see the poll results, right?
Yeah.
So I think, as usual, just like last time, option B got the highest vote. 45% of people voted. And then you have C, and then you have A. So please.
Well, let's see. So option B, it has a very low mechanical resistance. So it's a very low filler. Okay. It's a very low filler content. It's easy to apply, of course. It's rot resistant. But of course, it has a Marshall stability of high because the VFB is a very, very determining factor. And given the good bitumen content also and thickness, it provides a reasonably good Marshall stability. But it is a rot sensitive. It's also very easy to apply. I would say it's a very interesting option. So I would take it as a second option. While option A is significantly rot resistant because it is gap grade, and gap grade are based on the stone skeleton structure. It means that you have a small stone by a stone by a stone because you have a high share of coarse aggregates and you have a high share of binder, which is not only expecting the structural resilience from the binder with the mix of bitumens and filler, but also with the stone structure that provide a great rotting resistance. One of these examples would be a stone mastic asphalt, for example. It's very expensive. I mean, should not say very expensive, relatively expensive. It might be 1.3 of conventional cost, but it is a efficient and cost-effective option. Option C is a frost asphalt. We are not interested in frost asphalt. It has a really not much of the structural value for us. It's very good for drainage and noise reduction, of course. So for this particular stress source as extreme temperature, I would probably choose the option A. So let's go back to the first question, and now let's include both precipitation and temperature as a hazard system. So hazard system is how many hazard are we including in our basket of the hazard that we would like to study. In this hazard system, we have two hazard agents, precipitation and temperature. I think that might be, for example, in Bangladesh the case. So same options as the first questions. Now, if you remember, the option A was, we speculate that the option A might be the good option. But what if we add extreme temperature to the precipitation in this form? So which option would be now more likely to be resilient to both heavy precipitation and extreme temperature? I think after 5-10 seconds, you can open the polls. Are we done with the poll?
Not yet. I believe we still have few seconds left. Oh.
All right.
Yeah. And this time, I think we have option A, the highest vote, 53%. And then very close, option C and option B, 26% and 21%.
Great. I really appreciate that you participate, because it's all matter that we put thought on this. Have some few seconds of the thinking about that. Sometimes in practice, we don't get the luxury of having more information than what we have here. But of course, we need the more sophisticated investigation. We need to get much deeper and investigate the problem in wider spectrum. But sometimes the reality like this. Let's see the options here. Option A is a very great option for extreme heat, but for heavy precipitation, other way around. It's very good for heavy precipitation, as we discussed in the first question, but for extreme heat, it's not a good one, because the anti-stripper agent does not really increase the strength of the binder, and it's only reduce the moisture sensitivity. And since we have a high air void, so that means that we are very rot sensitive. Option B, on the other hand, is very good, because we discussed that it's a polymer modified bitumen. It shows significantly good behavior regarding the extreme heat and the rotting. But as we discussed in the first question, it is not a good option for heavy precipitation. Option C, however, definitely not good for extreme heat, and for heavy precipitation, we need more data. So let's go back to the scope of the resilience analysis here. So the idea is here that we want to reach from the scope to the properties. We want to select the properties based on the scope, and from the properties arrive at the attributes that we can sort of somehow select among the attributes, and then go to each, for example, road sections and do the screening and collect the data and provide some sort of evaluation that give us impression of how resilient is our assets under investigation. For that, for example, let's have one example. Let's say that we choose hazard as extreme precipitation primary. And of course, hazard system is not just only about the one, that's very important also in design. We should not just get one hazard as a leading governing factor, but it's always about the combination of the hazards. Let's say life is in the life cycle, we select the life cycle considering the climate change, recognizing the impact of the climate change for asset with the 80% of the design life. But of course, we should consider that when the design life is 10 years, it's almost negligible, the impact of climate change regarding the extreme temperature. In 10 years, we design the road assets, but if, for example, in the asset with the longer service life or design life, like a bridge, culverts, or highways, with, for example, we design for 30 years, we should absolutely take into account the impact of climate change. And let's say temporality, we would like to consider evaluate our assets based on ex ante and ex post, before and their behavior after the event. The system level would be pavement system. We also want to have a look at this network level impact, and the spatial scale would be rural and in province level. Dimension would be just technical. We don't have much luxury of evaluating in all, for example, possible dimensions. And level of the effort, so I think that is a concern of everybody, level of efforts, that we would like to not conduct really sophisticated modeling, lab tests. So we want to have our experts go on the site, observe the assets condition, do some survey, visual inspection, and provide some engineering informed data. And the intervention phase is preparedness, means that we are not at this evaluation, at this analysis, we choose not to look at the recovery capacities. So based on that, we might really end up with two properties from that 4 properties of the Bruno and his colleagues 2003 about the robustness and redundancy. Here, but before I go to the indicators of this, again another question, but there's no poll here. So based on what I explained about the scope, the first question that we discussed, let's think now one moment that how this scoping here that I explained would mean for this question. When we wanted to evaluate the pavement regarding this resilience to heavy precipitation, which temporality we're considering? I would say perhaps we're considering ex ante, the preparedness, the robustness that you're interested before the event. On which dimension? Absolutely technical, physical assets. And which system level? If it's an asset level, it's a component level evaluation. You're not actually looking at any network characteristics. And which property of the resilience? So it's clear that it's a robustness. And our analyzer's input would be like engineering informed, would be asset lab sheets, would be the construction document or maintenance reports. So regarding the two properties that we choose to further our investigation, for robustness, there are several factors contributing to a strength and resistance of the road assets to heavy precipitation. So that is the properties that we consider for assets exposed to water-induced hazard. What is very important one is drainage capacity of the base course. We don't want that our base course cause to trap up water or poor water pressure, which is the hydraulic force of the water, contribute to show itself as a kind of convex curve and make our pavement significantly susceptible to compressive strain or flexural strains. Drainage capacity of the varying course, it's also important. Attributes such as macro texture, that is preventing from hydroplaning, and it's actually provide some sort of surface drainage through the very overlay of the road. So in some mixtures, some pavement, the macro texture can be even up to 2 millimeters. But in normal asphalt concrete, it's normally something between 0.5 and 1. Surface drainage capacity, that we have a side dish, it's performing well. Then about the shoulders, is it paved, is it sealed, unsealed, partially sealed? The permeability of the surface, if it is gap grade, is it the rigid pavement, for example, if it's a sorry, if it's the dense grade asphalt mixture, and the moisture resistance of varying, which is actually depending of the aggregate and additive we use. So for example, aggregate with the origin of the rivering environment, they are highly exposed and highly sensitive to the water, because they have a high content of silicon dioxides, which is make them hydrophobic, and then therefore they would not provide a good binding between aggregate and bitumen. And moisture sensitivity of the subgrade, which is actually driven by the soil type, thickness, if we are using a stabilized subgrade over it, a capping layer or not. Then about the redundancy. Redundancy is absolutely not about only have a one alternative way, one alternative road that connect the same one alternative links that connect the same two nodes as our major road under investigation. It can be also about the mode redundancy. Maybe they won't be able to use the usual vehicles, but they can have other mode of transportation to just transport in emergency cases. And they should have the alternative route should have a meaningful different level of susceptibility. So if it's a same road with the same elevation in the vicinity, in the close distance of the original road. So if there's a flood, there are both damaged. So having two roads, it does not really provide any susceptibility privilege. Or it has a different level of exposure. There should be exposure privilege for the alternative route. With some sort of, it's less, for example, exposed regarding its direction, longitudinal, or location. It's less, for example, exposed to the flash flood. It's not a distance to rivering environment, therefore less exposed to the rivering erosion. Then there is another one that is important, that we consider also additional imposed travel cost. So if we have an alternative road, but then it needs like 2 times or 3 times more travel cost. Travel cost can be determined as a travel time or monetary value of the travel. It does not really make much sense to consider that. So it's not always about the 1 and 0. It's not a binary. It's a degree of redundancy that we should arrive at in a fuzzy manner. And safety and inclusivity. So we might have really alternative route, but that would not be proper or convenient for some group of user, disadvantaged user with a social vulnerability, with disability, or based on the gender, they are less likely to use that route. Therefore, these options we should consider when we are approaching to investigating the redundancy. So let's talk about the option that the indicator that I previously discussed. Stripping is one of the major problems that we see in the areas with the moisture sensitivity and highly exposure to the precipitation. And it's usually based on the theory that the aggregate with more than 50 to 65% of the silicon might exhibit the acidity environment, and therefore it's here, if you see, they are more hydrophobic. They are they are scared of the bitumen, and they do not really provide a cover that we really intend and wish to have. So, but it's when they are hydrophilic, they love the water. It's like the bitumen is the aggregate is hugging his long lost uncle, and so therefore provide a good amount of cover. And that's what we don't want to have, but this full coverage, which is easily can be achievable by using some anti-strippers. And anti-strippers are hugely important for us for the areas of susceptibility. Base layer is very important. That's why we have 2 indicators that addressing a baseline, not only the thickness, but also the hydraulic conductivity. So it's one study shows that the thickness of the bitumen to resistance the groundwater rise, for example, should significantly increase. I mean, I would call it significantly increased to be not anymore in the risk area. The change in the moisture content, the saturation degree, is very important for both base layer and subgrade. You can see that with the change in the moisture content, how much resilience modulus you will lose, the very important parameter we use in the design of the pavement system. And age and surface condition, I think that's something you all agree that the surface condition and cracks, for example, can allow for infiltration of the water. And this study actually shows, very good study shows that how uncracked surface behave differently, perform differently comparing to the cracked surface. And drainage system is also very important. So a pavement with a similar structure, but different drainage structure or condition can show significantly different behavior regarding degree of saturation. Based on that, the structural capacity of the pavement with a fair, let's say, functioning drainage application recovers considerably faster after rainfall, while the pavement with a poor drainage capacity stay with a lower structural capacity for a relatively longer time. It might take even up to 3 years that the subgrade is totally drained out from the impact of flood. And from 1 to 3 years, there's a time of the possible time of the recovery that the subgrade, the pavement system, regained its strength, in which it's lost due to saturation. And through this age, through this 0 to 3 age, it can lose up to 60% of its load-bearing capacity, or CBR, just because it has been fully soaked in the soaked condition. So that's recovery time is also significantly depends to the available drainage capacity, which I see mostly in the South Asia is a significant problem.
I'm very sorry to interrupt you here, but I think we are running out of time. So so if we can wrap it up in like next couple of minutes, let's say 3 to 4 minutes, then we can move on to the question.
I'm optimistic that is not that is possible. I'm trying my best. So thank you. The type of the type of the subgrade is also important. For example, if you use a sand subgrade, silt or clay, I mean that's something that we have not much choice. So you can see how much time it takes, and between 3 different floods, and how would be the total damage for different 3 soil type. So here we actually offer some sort of options for adaptation options, but you can see that there is some sort of resilience window. So where you want to build the resilience, you want to build it in the design, construction, I mean, or operational phase. Of course, if you don't want to see only robustness, you can also use the risk assessment method in the planning phase. It's very important where you locate your assets. In the design phase, it's depending on what is your strategy. You can, for example, for varying cores, have a strategy of letting the water drain down and then do the drainage system with a subsurface drainage, or you just start to have a different strategy than using for example, lower air void design to not let the water infiltrate from since the beginning. So there are some options. Maybe we need another webinar, 40 minutes, to just talk each by each. But when you have this slide, you can really study that. Then we have a gap grade and dense grade that we already discussed in one of the questions. So the gap grades, actually, they are kind of broken curve, and they have a high share of the coarse aggregate and high share of the filler, unlike the normal conventional and continuous gradation of our normal conventional asphalt concrete. Open grade, however, there are just lots of coarse aggregate and very little, let's say, aggregate between around the sieve number 4, And then they have a high amount of airborne as well. So there are different possibilities. So we should not just go with one option, but we have to have a choice variability to choose based on the degree of exposure, and of course recorded or observed damage that have been seen in the road asset. Even these days, they are still initiating the efforts to develop some, they call it progressive mastic asphalt. Here you see that it doesn't even need a roller for compacting the asphalt. It's just self-compacting asphalt. Is significantly rot resistant, but of course it's very costly and expensive. You can modify your bitumens with additives that we have different additive, Fischer-Tropsch wax, Monton wax, amide wax. The amide wax are very good anti-strippers. There are hundreds of anti-strippers. I think is regionally also produced very often. And you see how different anti-stripper can really impact the adhesion. It significantly can impact the adhesion and the scope of the bitumen and the aggregates. So one based on the Nussler theory, using just 3% of 0.3% of the additive can significantly improve the performance of your adhesion of your aggregate and bitumen. Or you use the modifiers such as polymers, either elastomer or thermoplastics, and increase the rotting resistance, as we discussed earlier, and how, for example, for SMA, using the PM polymer modified after 20,000, this amount of rotting would end at 1.5. Normally, this is for normal conventional asphalt, comes something at 7-8 centimeters. So here the Hamburg wheel truck test. I don't know if it's available, and I think it's in my last slide. If I don't have to run, let me take a moment. Here you can see there are different tasks toward building resilience, and one important one is integrate exposure and hazard risk assessment into the planning phase. It's very important that we are already aware of what is happening to our assets before we already start the alignment, road allocation, and so forth. The change in designing, but in some cases you don't need to really change the design, but what should be changed is design input that we are feeding our design process. For example, let's say exceedance probability. We don't really need to change that from the 20 to 30 years. Probably we don't get the result if we change the flood interval period. But what is we should change is the input of our hydrologic model based on that the possible climate change induced flood of the 30 years in future would have a higher velocity or we'd have a higher discharge rate. And then something is very important that we should include the climate information, exceptionally the precipitation and temperature, as a governing factor, as a leading factor of the design process. So far, what I see in the South Asia is always about the CBR, about the axial loading. Of course, they are important, but they are not the only hazards. There are lots of countries already started in Australia. Climate zones are Australia are inevitable part of the design. Frost depth in Germany. So if you open the German design standard, just see that next to the traffic loading, there's a frost depth also. Flood probability is used in Netherlands. Design is definitely always consulted, and climate modeling, for example, is also precipitation, UV temperature is used. A mechanical empirical pavement design guideline. They have also one fully integrated climate model within that to account for the climate information. And this climate information should be definitely up to date. The flood information of 1982 might not be really the reliable input for our design. New material based on the vulnerability, we should maybe do one webinar about the new materials and innovative materials. There are lots of misunderstanding about that. Enhanced level of investigation, simplification is the hazard itself. I see that we would like to have a design very quickly and exactly with the design that we understand, but Believe me, guys, we need a more sophisticated level of investigation. We need to dedicate time and effort for problem structuring, collecting data, analyzing data, and tailor our design for the hazard that our asset will experience in the design life. Hazard risk sensitive maintenance regime, and of course there are lots of constraints and limitations that the road agencies are facing. For example, road agency would like to control the water ground table, but another agency, let's say agriculture, would say that no, I want to have more watering from my agriculture sector here. So there are some sort of, or managing a detention drainage basin, managing the watershed basin is really require the collaboration between different agencies. Redundancy is very important for critical assets. Either they are critical or vulnerable or highly exposed. So you should really find out a trade-off between these three indicators to use that. Resource allocation for actually supporting the rapidity, life cycle, system level thinking, and multidisciplinary thinking. Lots of this resilience analysis, prioritization, they all require high degree of multidisciplinary knowledge. For example, you should be very much aware of uncertainty. Uncertainty is your best, uncertainty analysis is your best friend. Be very sensitive about the decisions, about the decision recommendation you get from decision models. They are very much, can be actually misleading if we don't really go through finding the uncertainty sources, because they are really vulnerable to the different errors and bias, both errors and cognitive biases. So we should have a knowledge of the conducting the good decision analytics in our planning and prioritization. And one of the most important things is asset level enriched data. So we don't have much chance if we don't have enough information. Information is our tool, data is our tool. So we should really provide that. And of course, we should keep doing the engineering capacity and knowledge development in our region. Thank you very much for bearing with me. It was probably a long one. If there's any question, I'm happy to answer.
Yeah, thank you, Milad. That was actually very, I believe it was very intriguing for a lot of participants, and there were several questions, and the timing is a bit short from our end, but there, in the chat box, there were several questions while we were presenting. Most of them have been answered by our team, and I don't believe there are so many in there. But I have one question for you in the Q&A box. If you will like to give a quick answer to that. So we have road standards to guide, which may not be perfect. So I believe that the person who is asking the question is asking about the existing road standards. But what are the common problems with road standards that you think there are, especially in South Asia? So that I think the existing road standards, if there is any problem you have identified or you have seen, I think that is the question. You want to answer that, Milad?
Well, of course, thank you very much for posing this very important question. It's really required the large degree of discussion about that. So there are several aspects contributing. One of them are, as I said, oversimplification, catalog-based design. Another one is not including climate stressors as a defining factor. So, for example, in one of the documents I read, there was in other factors, there was written that some environmental factors should be considered. It is not sufficient. Another one is that inadequacy in the subject. So there are, for example, a topic addressing that, but they are not really providing the guide as a design engineer. What should I look for? The main thing that actually struck me is the lack of hydrologic guide for hydraulic design and for drainage system. Although the enemy number one in the road context is water. Water is destructive. As a frost, as its crystallization, as a moisture on the surface, as a force of water. In all cases, water is quite dangerous hazard agent. But we don't have as much as this significance of the hazardous nature knowledge material to provide a design engineer with sufficient support that consider that in the design. Another one is that sometimes we follow, for example, neighbor countries' design philosophy. The design philosophy, design principles to change. The design philosophy has nothing to do with the philosophy itself, but it's about the basic principles. For example, one of the problems is that we still think that low volume roads and rural roads are the same concept, but it is not true. Of course, in the US, in the Germany, the low volume roads are less important, but they are not the only access of the community. They are not used as much used as a rural ways that it is used in South Asia. South Asia, low volume roads are actually lifelines, although they exhibit their in this very limited traffic functionality classification is a low volume, but it is very important for the community. Another issue is that the traffic volume itself is not a sufficient factor for defining the importance of the road. So if there is the road with connected very important nodes together, but it is not having a high, especially in South Asian design standards, always counting the commercial vehicles. So it does not have a high commercial vehicle traffic. It will be deprived from better structural attention. But this importance should be defined based on the criticality of the nodes. Criticality of the nodes, the link attach, connect, and the criticality of the link itself. That's for now.
Yeah, thank you, Milad. I actually also kind of have the same view on how we should be focusing more on the criticality rather than only focusing on the volume of traffic while we are designing our roads, and which is actually one of the main issues that can be identified for our roads in the South Asian regions. So thank you, Milad. I believe we do not have any more questions for you at this moment, but I'm quite sure people will come back to you at your milad.zamanifer@adpc.net email, and we will probably hear from you more in the future. So thank you once again. And since we are running behind our time, just for our closing remarks, I'm gonna ask our last speaker for today's session, Muhammad Nurul Alam. He is the ADPC's Resilient Infrastructure Specialist and currently based in Bangkok and Thailand, and currently leading the resilient transport sector of World Bank's Care for South Asia project on behalf of ADPC. And he's published several technical papers on seismic vulnerability and risk assessment and mitigation, and working experience on vulnerability and risk assessment leading to multi-hazard retrofitting for social and economic infrastructure. So Mr. Alam is from Bangladesh, and he has completed his bachelor's from BUET and pursued his master's degree from University of British Columbia. So without further ado, let us just welcome Mr. Nurul Alam, and he will be providing our closing remarks for today's session. The floor is yours, Mr. Nurul Alam.
Thank you so much, Noreen. Am I audible?
Yes, you are.
Okay, thank you so much, and thanks a lot to all the audience that I can see. Most of the audience were very much engaged, and still I can see almost everyone is still there, which is a very good sign, and thank you so much. And over there, of course, the session was a bit technical in terms of transportation, but I believe some of the major aspect of the basics on the resilient infrastructure, mostly on the transport, has been a little bit cleared, which of course we can move ahead with this. And just to assure you, this is not the end, this is just a beginning. And as you see, there was a query also about for Dr. Peranan, which I would like to respond here while closing it up. Like, of course, we are working on several projects, and we saw this evidence generating experiences. One is in Southeast Asia under the survey project, where we are using the satellite technology to see that over the years of generated maps, how the decision can be taken. Where the second one is, of course, this Care for South Asia, which has two major components. One is the climate resilient decision support tool, which RIMES is working on, one of our counter partner for component one. ADPC is working on the policies and the guideline, how our stakeholders can use the DSS decision support tool to take an informed policy, informed decision for resilient infrastructure. Where if you see this resilient transport, it would not only offer technical guidelines that Milad is looking at for climate resilient roads and bridges, but would also share recommendations and framework for South Asia based on the demonstrated experiences in Bangladesh and Nepal to help climate risk informed decisions. The pioneering regional guidelines for climate resilient roads and bridges that is going to help to identify the gaps of the current national roads and bridges design standards in South Asia and to offer recommendations to update those standards. Initiating capacity building program, and one is of course this kind of webinars, and there will be a lot of online training for that program. And entering into partnership with relevant department, we are quite happy to see our sectoral focal points here also from local government engineering department, Department of Roads in Nepal, Department of Local Infrastructure in Nepal, and LGD of course in Bangladesh. And we are having very effective partnership with them and also with the international organization, which would be the core of the sector's activity. Well, I'm saying all these things that we will reach out to all of you very soon again with several kind of activities in future. And if you say that all of our people you saw in the panel are part of our ADPC, either the country offices or the Bangkok offices. And feel free to just drop a message, any of us, like here email addresses are given from Milad if it is related to the road standard, or Anish if it is related to any of those risk assessment part, or feel free to connect us in the ADPC email itself. Having said that, thank you so much again to join this wonderful event, and I'm especially thanking Milad and also the participants here to attend this very nice webinar, and I hope it was useful for everyone, and we will move forward with that. Having said that, over to you, Norinapa. Would like to close this session for now. Thank you.
Thank you so much, Mr. Nurul Alam. And this has been an interesting 90 minutes with all of you. And we actually are very thankful that from all over the world, especially from the South Asian region, you could join, despite all of us, all of you having busy schedules at office or maybe with family. But you have rendered this wonderful time with us. And I'm signing off on behalf of our team, and here is the whole team. I believe you can all see, now you can see the whole team behind the session here. And thanking once again, and have a good night, have a good evening, and have a good afternoon, everyone. And we will see you once again sometime in the near future.
Thank you.
Bye-bye.
Thanks, everyone. Bye-bye.
Bye.